Hi there, thanks for clicking on and watching. Welcome to this video. If you're preparing to sit Maths A level this summer, and particularly if you've got mock exams after half term, you're going to find this video useful because we're going to go through some stats and mechanics. All the topics included should be material that you've seen already. So a good idea would be to pause the video, have a go at the questions and then watch my solutions. I'll put timestamps in the description, so if you want to just look at a particular topic, you can find the timestamps there. So here we go with question 1. We've got this sequence being described with the letter A. We can see it's a recurrence relationship because what do we do with the one before? We need to do 4 minus the previous term. So if A1 is 3, finding the second term is just going to put it in that recurrence formula. It's going to be 4 minus 3, which is equal to 1. Now it's always worth doing a few more terms and let's see what's going on. So A3 will put the 1 into the recurrence relationship and do 4 minus 1, which takes us back to 3. And we know when we put 3 in, we got 1. So we're going to have a periodic sequence that's going to start 3, 1, 3, 1, and just keep going like that and so on. Every time you put 3 in, you get 1, and every time you put 1 in, you get 3. So for the next part, to get the A107, that is an odd term of the sequence, and we know when we get to the first and the third term, that's 3. So A107 is going to be 3. Now the information at the top of the question refers to both A and B, because you might think you're doing a sum here of a 2n minus 1 sort of linear sequence, but this is not telling you to do this. An is being described up here. So the first term that we need to put in is this 3. 2 times 3 is 6 and minus 1 is 5. So the first term in this summation that we're being asked when we're doing a little function of the sequence already described in part A is telling us to put 3 in and we're going to get 5. When we put the 1 in, which is our A2, double 1 is 2 and minus 1 is 1. And then this is just going to be periodic like the one above, because the A recurrence relationship does apply to both parts A and B. So if we want to sum up 200 terms, every 2 terms, if we add them together, comes to 6. So we are going to have 100 pairs of 6. So the sum is just going to equal 6 times 100, which is equal to 600 as our answer. In question 2, we want to have no real roots, so we want b squared minus 4ac to be less than 0. Our b is all of 6k, so that's going to be 36k squared for b squared, minus 4 times k, and then times 5 for c. So 36k squared minus 20k has to be less than 0. This is a quadratic inequality, so let's take 4k out. And then we'll have 9k minus 5 is less than 0. Now we wanted to equate that to 0. Where would the solutions or the roots be? They'd be at k is equal to 0 or k is equal to 5/9. So if I was plotting this quadratic, it would go through at 0 and 5/9, and we want this quadratic to be less than 0. So the range, whenever you're asked for a range, it's an inequality and k is non-zero, so k is between 0 and 5/9, and then we will have no real roots. In this next question, we've got an equation of a circle given here. We're asked to find the coordinates of the centre C, so we need to complete the square. It's going to be half that position with the x term, so that's x minus 10 all squared, and then minus the square of that number there, and then plus y minus half of what's in front of the y minus 8 all squared minus the square of that number there is 64, plus the 139 is equal to 0. Tidying that up and taking all the constants to the other side, that all comes to 25 on the other side. So the centre is going to be the opposites of these brackets here. It's going to be 10, 8, and the radius is equal to the square root of 25, which is equal to 5. In part C, we've got the equation of the line x equals 13, finding the points P and Q. So if we know that x is equal to 13, we can just sub 13 in here to our equation of a circle. So 13 minus 10 will be 3, and 3 squared is 9, plus, and then we can square out this bracket, so that'll be y squared minus 16y plus 64 equals 25. Everything to one side. Let's get the quadratic term positive. So it's y squared minus 16y, and then, oh, why have I written 9 squared? It's just 9. 9 plus the 64 and minus the 25 on the other side is going to be plus 48. And then we just factorize y and y. Signs need to be the same, but negatives are involved. That tells me they're both negative. We need two numbers to times together to give us 48, but going down, both of them, we're going to end up at minus 16. So that's minus 4 and minus 12. So y is 4, or y is equal to 12. So Q is going to be the point 13, 4, that's lower, and then P will be the point 13, 12. Part D, it asks us to find in third form the length of OX, given that we're drawing a tangent from the circle to from O to touch at point X. So here's point O, the origin. We need to draw a tangent. Now we could draw it there, or we could draw it there. We know from our circle theorems that those are actually the same length. So let's just look at one of them. Should we go here as our point X? Now we know that when you have a radius meeting a tangent, they meet at 90 degrees. And then if we go up to the center, we know because the center is at 10, 8, then the length of that line, just doing some Pythagoras on that, so it'll be 10, 8. Then this is going to be the square root of 164. We know that the radius is 5, so if we do some Pythagoras on that right angle triangle and do 164 minus 25, take the square root of that, OX is going to be the square root of 139. In the next question, we've got a quotient here. We're being asked to find dy by dx and put it in this form. So we're going to use the quotient rule, which is the bottom cos x plus sin x differential of the top, which is just 3 cos x, minus the top 2 plus 3 sin x differential of bottom, which is minus sin x plus cos x, all over the bottom squared. So that is cos x plus sin x all squared. So multiplying this out, we're going to get 3 cos squared x plus 3 cos x sin x. Then minus, now these two brackets, we need to minus all the terms. We're going to put some brackets and then just FOIL these out. So it's first, which is minus 2 sin x, then the outers, which is plus 2 cos x, and then the inners, which is minus 3 sin squared x, and then the lasts, which is plus 3 sin x cos x. And then again, we're just all over our cos x plus sin x squared. Let's square that out. It's cos squared x plus 2 cos x sin x plus sin squared x. Okay, so we've got 3 cos squared here, and when this minus goes in here, we're going to have another 3 sin squared. So if I put those together, I can take 3 out as a common factor and have cos squared x plus sin squared x, and cos squared x plus sin squared is 1, so I'm just really going to get the number 3. So that's dealing with that term and that term. I've got a plus 3 cos x sin x, and here when this minus goes in, this is a minus 3 sin x cos x. I've just written them the other way around, but they're the same term, so they're going to cancel. and then I've got a minus and a minus, so it's going to be plus 2 sine x and then minus 2 cos x, and that's dealing with all the terms on the top. Now what on the bottom, we've got a cos squared plus a sine squared, that's going to equal 1 plus a 2, and let's write this as sine x cos x. So that's just going to be 3, and that's times by 1, so we can just forget about that bit there. So now in order to get where we want to go, we can see we want some tans and some secs. Sec is 1 over cos, so if I divide through all the terms by cos x, then that will give me, if I put some cos x underneath there, that's where my tan's going to come from. This is where a number's going to come from, and then this is where a sec's going to come from. And so I just need to do the same thing throughout, and then the whole fraction stays in the same proportion because I'm doing the same to everything. So the 3 over the cos x is going to be 3 sec x, and then plus 2 tan x, and then minus 2 all over sec x, and then these cos's will cancel and we'll have plus 2 sine x. So that's how we needed to get to where we wanted to go. Just thinking about how we get to tans and secs, we just needed to divide through by cos x. So in front of our tan, we can see here a is equal to 2. In front of our sec, we can see that b is equal to 3 and c is equal to minus 2. And we kind of think and hope we're correct because we've got the same denominator on the bottom. Next, we've got a proof by contradiction, and we've got to prove that if n is an integer, n squared minus 2 is never divisible by 4. So when you're doing a proof by contradiction, you have to assume the opposite. So you have to negate what you're trying to prove. So we'll assume that n squared minus 2 is divisible by 4. We go through our proof and realize that we've made a contradiction, so our original assumption must have been false. That's how we set them out. So if we assume n squared minus 2 is divisible by 4, then n squared minus 2 must equal some multiple of 4, say 4k. So n squared minus 2, just take the minus 2 to the side, n squared is equal to 4k plus 2, which is 2 times 2k plus 1. So this is an even number because we've got that multiple of 2 on the front. If n squared is even, then n is even. So if n is equal to, say, 2m, n squared is equal to 4m squared, which is a multiple of 4. So n squared minus 2 is equal to 4m squared minus 2, which is 2 less than a multiple of 4. So we have a contradiction. As 4m squared minus 2 is not a multiple of 4. So then our original statement must be false. So therefore, n squared minus 2 is never divisible by 4. In this next question, we've got this modulus graph, and we can see it's a transformation. So I like to just start from the inside of the modulus and then think what that graph, and then apply these two transformations. And the idea is to try and see if I can get some values on this y-axis. So just thinking about the line y is equal to 3 minus x. that is going to have y-axis intercept 3, and it's going to come down with a gradient of 1. Now when we put the mod lines in, that just means y can't be negative. So when we get to the x-axis, we don't go underneath, it's just going to reflect up. So that is the line y is equal to the mod of 3 minus x. When I'm drawing modulus graphs, I like to write on the equation of each side of the v. So this is going to be 3 minus x, and the other side is just going to be the opposite signs. So that's going to be x minus 3. Now what's happened is we've multiplied it by 2. So if you think when you've got 2 times a function, if you had y is equal to x squared or y is equal to 2x squared, a 2 on the front is going to just multiply all the y coordinates by 2. The y coordinate here, where on our v is 3, because if we equate the 3 minus x to 0, then x will have to be 3. So multiplying the y coordinates, which is 0 when we're on the x-axis, is going to stay on the ground, but this point here is going to go up to 6. All the y coordinates are going to times by 2. So that's where our v will go. And then a 5 on the end is just going to translate the graph 5 up. So the whole graph is going to go from 3 here, and it's going to move up 5 places. So that will take this place here to 3, 5, and this 6 y-axis intercept will go up to 11. So that is what our graph looks like. So this point here is 5 and this point here is 11. Now we're asked to find and solve the equation where this f of x is equal to half x plus 30. So I'm not going to fit into scale, but roughly if we do 30 up here and it's a half x, so it's quite a shallow line, you can see it's just going to meet the graph at one place. Because we're told that x has to be greater than 0 for our f of x, which is our modulus graph, then the graph does not extend for x equals 0. It's just x less than 0, it's just for x bigger than 0. So there's no extension there, so we can just see it's going to have one intercept. So what was the equation of the right hand side of our graph? It was x minus 3, but then times by 2 and then add 5. So that's going to be 2x minus 6 plus 5, which is 2x minus 1. So if we equate 2x minus 1 to half x plus 30, let's times everything by 2. 4x minus 2 is equal to x plus 60. 3x is equal to 62, so x is equal to 62 over 3. Now, without drawing the graph, you wouldn't kind of realize that it only intercepts once, so you might get that second answer, which would be here, which would be wrong because we're restricted with the domain x has to be bigger than 0. Now in part B, we're given the equation f of x equal to k. K is a constant. Remember that f of x is just the same as y, so y equals a constant k. So what does the graph y equals 3 look like? Y equals 3 is just a horizontal line that cuts the y-axis at 3. So it's asking us to draw a horizontal line such that it just has 2 distinct routes when we intersect with f of x. So f of x is just this black line, isn't it? And we just need to draw a horizontal line so that when we draw the line, it is going to intersect twice. Now, if we draw a line at y equals 5, we can see there's only one distinct route. So it's going to have to be a line that's higher than 5. So if we go higher than 5, there's 2 routes. If we go to 11, there's 2 routes there and there. Now, if we go higher than 11, it's just going to have 1 because the graph doesn't go to x being negative. So in order for having a horizontal line that's just going to intersect and have 2 routes, we need to have k being bigger than 5, because then when it's bigger it will have 2, but we need to have it less than or equal to 11. In this next question, we're being asked to use the substitution x is equal to 2 sine u, and to go from this integral to get something in terms of secs and tans. And we can see we've got to replace the dx, we've got to replace the x, we've got to replace x squared, and we've got to think about the limits. So let's get some dx on the go to start with. Now, x is in what we normally maybe have the u position or the y position. We're going to be doing dx by du and differentiating on the right with respect to u. So that's going to be 2 cos u. So dx will stand for 2 cos u du, just cross multiplying. And then thinking about this x squared will equal 4 sine squared u. The x we know is just going to be 2 sine u, and then looking at the limits, when x is equal to 1, 1 will equal 2 sine u, so a half is equal to sine u. So what angle when you take the sine of it is a half? 30 degrees, but when you're doing any calculus, that's differentiation or integration with trig, you must be in radians. So u is going to be 30 degrees in radians is pi by 6. So now we're ready to do our substitution. We're going from 0 to pi by 6 of 3x. So that will be 6 sine u plus 2 all over a 4 minus x squared, which is 4 sine squared u, and that denominator is raised to the 3 over 2 times by dx, so that's going to be 2 cos u du. Now we can see on the denominator here, if we just take 4 out, this will be 1 minus sine squared u, and 1 minus sine squared is cos squared, so it's actually going to be 4 cos squared u, but that is all raised to the 3 over 2. So taking the square root, dealing with the index half underneath, that will be 2 cos u, but then raising it to the power 3, it's going to be 8 cos cubed u. So let's just put that back in and see what's going to cancel. We're going from 0 to pi by 6 of 6 sine u plus 2 over now 8 cos cubed u, and then we've got a times 2 cos u du. So we can see this cos u is going to reduce that power on the bottom to 2. The 2 is going to cancel and give us a 4. Now we've got two terms in the numerator that are both being divided by 4 cos squared u. So let's separate them out. 0 to pi by 6 of 6 over 4, which is 3 over 2. Sine over cos squared, let's just write it as that, sine u over cos squared, plus 2 over 4, which is a half over cos squared u. So sine over cos squared, that's going to be sine u over cos u, just using one of the cos's on the bottom, which is tan, times 1 over cos. So that's actually going to be our 3 over 2 sec u tan u, and then plus half over cos squared, or 1 over 2 cos squared, which will be a half. Cos squared on the bottom, on the top will be sec squared u du. So there we've done it, and we've just got p is equal to pi by 6. So when it says hence find the exact value, because of what we've just done in part A, because it says hence we must use what we've just done. So it was from 0 to pi by 6 of 3 over 2 tan u sec u plus a half sec squared u du. Now we know that tan differentiates to sec squared, so the sec squared is just going to integrate back up to tan, so we know how to do that one. When we see tan sec, if you think about y is equal to sec u. So that is y is equal to cos to the minus 1 of u. If we differentiate sec, which is cos to the minus 1, we can use the chain rule, power down, which will be minus cos, take 1 off, minus 2u times the differential of the inside, which is minus sine u. And then tidying that up, we're going to have the minuses cancelling, and we'll have sine u over cos squared u, which we've already just done in part A, is a sine u over a cos u, which is tan, times 1 over cos u. So sec u differentiates to tan u sec u, and we've got to integrate that, so that's just going to integrate back up to sec u. So you either know that one and have learnt it, or just follow that along to see how it's going to work. So this is just going to all integrate to 3 over 2 sec u plus half of tan u, and we're going from 0 to pi by 6. Now let's do our special triangle. When we've got 30 degrees, sine 30 is a half, so the other side by Pythagoras is going to be root 3. We're trying to put 30 in, which is pi by 6, so this is going to be 3 over 2 of sec, which is 1 over cos of 30. Cos 30 is adjacent over hypotenuse, so that's root 3 over 2. But because it's sec, it's just going to be upside down, so that's going to be 2 over root 3. Plus a half of tan 30. Tan 30 is 1 over root 3. And then when we put the other limit in, sec of 0 is upside down of cos of 0, and cos of 0 is 1, so that's just going to be 3 over 2, and tan of 0 is 0, so for the second limit, that's all we have got. So we can see we've got a common denominator of 2 root 3, so let's just times this by root 3 over root 3, and then everything's got a common denominator. We can see these would cancel, but let's leave them as they are. So we've got 3 times 2, which is 6 over 2 root 3, plus 1 over 2 root 3, and then minus 3 root 3 over 2 root 3. So we've got, because we've got these common denominators, we've got 6 plus 1, 7 minus 3 root 3, all over 2 root 3. Now what we could do now, I suppose, is rationalise the denominator, times by root 3 over root 3. So that's going to be 7 root 3 minus 3 times 3, which is 9, all over 2 times 3, which is going to be 6. Onto the stats section, and we've got a binomial distribution, and we're doing a hypothesis test. We've got our null hypothesis is that we expect the probability of success to be 0.3, and our alternative is just that it's not equal to 0.3. So when we've got not equal, we don't know whether to expect below the 0.3 or above. This means we've got a two-tail test, and it does tell us that in the question, because we've got a 5% significance level, and we're doing rejection in each tail if it's less than 2.5. So when you've got a two-tail test, you just split the 5%, the significance level, half each in either of the tails. So for part A, we're being asked to use the 5% level and find the critical region, which is at the point at which we're going to be rejecting H0. Now we're assuming that H0 is true, so we think the probability of success is 0.3. So it's always worth looking that in 20 trials, if we expect 0.3, 0.3 is 3/10, 1/10 is 2, so 3/10 is going to be 6 expected successes. So on a scale where we could have no successes or 20 successes in our trials, we're expecting 6. So how low and below the expectation does it need to be, and how high and nearer the 20 does it need to be in order for us to reject that the success rate is 0.3, and so but therefore we would be expecting the 6. And we use the 2.5, and that's as a percentage, so that's going to be 0.025 as a probability. If the probability of getting so far below the 6 is going to be less than the 0.025, or so far above the 6 is going to be less than the 0.025, then these will be our critical regions. So in tables or on your calculator, if you do just a bit of trial and error or looking down the tables, you'll see that the probability that x is less than or equal to 1 is equal to 0.00764, and the probability of x being less than or equal to 2 goes above the 2.5%, so this is going to be our critical region. And then if we do the probability that x is bigger than or equal to 11, which is the same as 1 minus the probability of x being less than or equal to 10, which is 1 minus 0.9829, which gives us 0.0171. So these are our critical regions as long as x is less than or equal to 1 or x is above 11. So it would have to be 11 and then obviously less than the 20. So you don't need to state that, but in 20 trials we could only have it going up to 20. But these are our critical regions. Now for part B, we're asked to state the actual value. So that is just adding up the probabilities that we found. So when we do 0.00764 plus the 0.0171, we should get that it is 0.00247. So it's actually 2.47%. Part C, state a conclusion that can be drawn because the actual value of x obtained is 3. Now, given that we're expecting 6, and if we're less than 1, so 0 or 1 successes, we're going to be rejecting the H naught. The fact that we've got 3 is still within the realms of possibility that it's obviously below 6, but it's not so far beyond it that the probability of it happening is going to be less than the significance level. So as 3 is still in the region where we would be still accepting H0, we can say that there's insufficient evidence at the 5% level that P is not 0.3, and we would be accepting the null hypothesis. The next question is a normal distribution question. We don't know what the mean is, but each packet is supposed to contain 1 kilograms of powder. All these weights down here are in grams, so that's going to be 1,000 grams. To comply with regulations, each packet should be selected so that the probability if that packet contains a weight 30 down from the mean, then the probability of that happening is 0.0005. So let's put that information on our bell-shaped curve. We've got our mean mu that we don't know in the middle. Now everything up to mu minus 30, this information is telling us that the probability of that is 0.005, and the probabilities are represented by areas under the curve. Now if we do inverse normal on the 0.005, when we do inverse normal the areas have to be to the left, so this is, we'll get a z value of minus 3.2905. We need to use z values because we haven't got the mean, and the z values is the standard normal, so z is normally distributed with mean 0 and standard deviation and variance 1. So how do we toggle from the standard normal to any old normal? We use the formula z is equal to x minus mu all over sigma. So let's put that information in. Minus 0.32905 is equal to x, which is our value on the x-axis there, mu minus 30 minus the mu all over the standard deviation. Now what's going to happen here is the mu's will cancel. We can cross multiply and get that our standard deviation is going to be minus 30 over the minus 3.2905, which does equal the standard deviation of 9.117. So that's how we do part A using inverse normal. On to part B, we're told we've got a random sample of 10 packets and here's all their weights. So we're going to be doing a hypothesis test on this sample here, and the mean of the samples is also going to be 1,000 grams, and what we need to do is find the mean of this sample. So x bar, if we add all them up and divide by 10, that comes to 999.54. Now, stating our hypotheses, it says here that we need to use a 1% significance level whether or not the machine is delivering packets with a mean weight of less than 1 kilogram. So because of this wording less, we're going to be doing a one-tailed test. Our null hypothesis is we are assuming that mu is still equal to 1,000, and H1, because of that wording, is that we think it's less than 1,000. Now, our sample has got a mean of 999.54, which is less, so we need to use the 1% level. But because we've got a sample, our sample means are also normally distributed with 1,000, and then it's the 9.117 divided by sample size, and all that needs to be squared because it's variance that goes in there. So when we're going to be using our calculators, our standard deviation is going to be 9.117 divided by the square root of 10, and that's because we've got a sample. So what we need to do is find the probability that x is going to be less than the 999.54 based on this being true, and when you put that into your calculator you get that comes out to be 0.4366, which is 43.66%. Now 43.66 is obviously bigger than our 1%, so we can say that there is insufficient evidence to suggest that the mean is not 1,000 grams or 1 kilogram because the sample is so close to the 1,000, and the probability of that happening is 43.66%. Now, the other thing you can do is find the relevant Z value using the 9.54, and that comes out to be equal to minus 0.16, and then the 1% level Z value is minus 2.326, and obviously that value is higher than the Z value, and that's another way to get the answer that we're going to be accepting H0, insufficient evidence to suggest that the mean is less than 1 kilogram. On to the mechanics section, and we've got a boat moving at constant velocity. Now, as soon as we know we're going at constant velocity, we're thinking that speed is just equal to distance over time. We've got a starting point of B being 3I minus 4J, and 2.5 hours later at 2:30, then the boat is at 8I plus 11J. We're trying to find the velocity, which is how fast it's going each hour. So speed is equal to distance over time when it's a constant, and then the fact that we're in I and J's will give us the direction. So when we have something coming from a common origin, say it starts at A and then goes to B, and that we've got vectors that get us to those two positions, in order to find the distance from A to B, we need to go back down A and then along B. So A to B, that journey is just going to be B minus A, which in this case is where we are at B, which is 8:11 minus the 3 minus 4, which is going to give us 8 minus 3, 5, and 11 minus 4, 15. So that is the distance, but it's taken us 2.5 hours to do that. So how do we find the speed? It's distance over time, and the fact that we've got it in I and J direction will give us the velocity because it's going to have size and direction. So the velocity is just going to be dividing both of these components by 2.5. How many 2.5s in 5? There are 2, so we're going 2I every hour. And how many 2.5s in 15? Where there are 6. So it is 2I plus 6J kilometers per hour. Now in part B, at time t hours after noon, what is the position of B? So the position, the distance is just going to be the speed times the time. And we can use velocity because we've actually got it in the components. So all we've got to do is every hour we're going to be moving in units of the 2i plus 6j, but we just need to account for where we started at. So where the boat is going to be t hours later is going to be 3i minus 4j, its starting position, plus the 2i plus 6j times t, because it moves in that direction every hour. On to the last question, we've got this Pulley's question. P and Q have masses of 0.5 and m. M is less than 0.5. So when the system is released from rest, we can see P is going to move down and Q is going to go up. The particles are connected by a light and extensible string, which means that the same acceleration is going to be throughout. The string passes over a smooth pulley, so we've got not got any friction at the pulley. Initially, P is 3.15 meters and the particles are released from rest with the string taut, and P descends for 1.5 seconds before it hits the ground. So for part A, we're being asked to find that the acceleration is 2.8. So for this, we need to use our suvat equations. So let's fill in. P is going to be traveling for 3.15 meters. It's released from rest, so our initial velocity is 0. A we're trying to find, and it's going to be traveling for 1.5 seconds. So when I do my suvats, I put a question mark against the one I'm trying to find and leave blank the one that I haven't got, and think of a suvat equation that doesn't involve V. So that is going to be S is equal to UT plus half AT squared. So filling in the values, 3.15 is equal to 0 plus a half times A times 1.5 squared. Just cross multiply, that is going to give us that A is equal to the 2.8 meters per second squared. Now on to B, finding the tension in the string. So tension is a force, so we need to start putting the forces on. We're going to have 0.5 G acting down from P. We're going to have mg acting down from Q. The tension is the same throughout the string and they're acting up. Now we're going to apply F equals ma for both of the particles. So for P, what's taking it down is the 0.5 G minus the tension, which is dragging it back because Q is connected at the other end. So that is equal to ma. The m is 0.5 and we've just found that the a is 2.8. Then for Q is going to move up. So what's taking it up is the tension minus the mg is equal to 2.8 m. Now we don't really need Q's equation of motion. We can just get T from the P one because we've just got one unknown there. So if we just take that to the other side, we're going to get that T is equal to 0.5 G minus the 0.5 times the 2.8. So T comes out to be 3.5 newtons. For part C, being asked to show that m is 5/18. So using Q's equation of motion that we've just found here, we can say that 3.5, which is the tension, minus the mg is equal to 2.8 m. Just take that to the other side. 3.5 is equal to m, and take out our g plus 2.8. And then just cross multiply, we'll get that m is 3.5 divided by our g plus 2.8. G is our 9.8, and if you do 3.5 divided by the g plus the 2.8, we'll get that m comes out to be 5/18, and that will be in kilograms. Part D. State how you use the information that the string is inextensible. Both particles have the same acceleration. from rest, so from the beginning of when the system is released. Then on to part E. When P strikes the ground, P does not rebound and the string becomes slack. Particle Q then moves freely under gravity without reaching the pulley until the string becomes taut again. We're being asked to find the time between the instant when P strikes the ground and the instant when the string becomes taut again. So for this, what we need to do is think about when P hits the ground, then obviously the string will be slack. Q will already have gone up, but then because it's in motion, it will continue to go up, but then it'll come back down at the point where the string will go taut. So what will stop it and bring it back down again is it will slow down due to being moved freely under gravity. So we're going to have a different acceleration, which is going to be the 9.8. And what we need to do is find when is the velocity 0 at the top of its height, and then find the time it takes to get there, and then we just double it up because it's just going to come back down again. So what we need to do is find the speed at which Q has when P strikes the ground. So when P strikes the ground, it will have travelled 3.15. We went from rest. We're trying to now find V. A is our 2.8 and T is 1.5. Now the easiest equation to use here is V is equal to U plus AT. So V is equal to 0 plus 2.8 times 1.5, and that comes out to be 4.2. So that is the final velocity when we're still moving under the system where the two particles are attached, and we've got that acceleration 2.8. So that is now going to be our initial velocity when Q starts to move freely under gravity. So we now need to do a new suvats, and we're using our U is the final velocity, there is the new initial velocity. By the time it gets to the top of its height, it's going to have 0 velocity. The A is now minus 9.8, and we're looking for the time. So we're not interested in how far it's going, we're looking for how long it's going to take to get to the top of that height. So again, we're just going to use V is equal to U plus AT. So that is going to be 4.2 minus 9.8t, and that comes out to be, t comes out to be 3/7. So then the total time before it becomes taut again is going to be 2 times 3/7, which is 6/7 seconds. So it's going to take 3/7 of a second to get to the top of the height, and so it's going to just double up by the time the string becomes taut again. Thanks so much for watching. Hopefully you found the content of this video useful and helpful. Do like and subscribe. Check out the channel for some more help as you prepare for your Maths A-level this summer, and I'll see you on the next one.